All right, for the first lesson of Chapter 13, we're getting into now what we call set theory. So a lot of this just dealing with number sets and sets of objects and things like that. A lot of this has to do with notation. So pay real close attention to just all the little symbols and the notation and the vocab that we use, because that's definitely one of the key areas to this chapter. So here we go. So the first part of this, and if you look in your own book at sections 13.1 and 2, you can kind of look up your own definitions to some of these main things that we're going to be talking about for vocab, but I'll kind of highlight a couple things that you should know. But this whole chapter revolves around sets, and a set is simply a list of objects. And so that's what we'll associate with a set. It's just a list of objects. I'm going to abbreviate here. So just a list of objects. Braces are what we use when we identify a set of objects. And so if we had a list of objects like this, like 1, 2, and 3 would be a number set, and these are the braces that we use to surround it. So it's kind of that, I don't know, kind of bird-looking symbol, but these are your braces that we always wrap around our set of objects. Venn diagram is going to look something like this, and so I'll explain a little more about Venn diagrams when we get there to our first example. You'll be seeing some more of this guy right here. This is the symbol for the word element. So it looks like a kind of a weird E. That's the symbol that we use for elements. And the elements are simply the objects within a set. And so you can see by this example right here that 2 is an element of that number set right there. There's our 2, and so 2 is an element of that number set. Tabular form, again, you'll see down here in a second, so I'm going to save that one. One really key idea that you got to make sure you take note of right here is anytime you are asked to list the elements or to list a set, we always use braces. And so right here you see the braces around the list, but when you're specifically naming an element within a set, you don't put braces around that. And so there's no braces around here. He's a specific element. We just put the braces around the complete set. And so that's something you got to pay attention to. That you'll be tested on. So moving down here, if we get the first example, so we're going to use set notation, which is this idea right here of set notation, to identify the face cards within a deck of cards. Venn diagrams become a really big part of this chapter towards the end of the chapter, but we're going to just introduce them a little bit just so we can get our feet wet and make sure we understand what Venn diagrams are. But if you had a deck of cards, so if you see this rectangle right here, right? This represents the entire deck of cards. U is for universal set. So when you talk about a deck of cards, everything that's in that universe are these elements right here. And so these are all the elements within the universe of a deck of cards. So that's every possible value for the deck of cards. Well, within that little universe of a deck of cards, there are sets within a set. And so one of those kind of sets within a set would be the face cards that are in a deck of cards, like a jack, a queen, and a king. And so that is a set within a set. And so if we were talking about a deck of cards and we wanted to do this in set notation, it would look something like this. So keep in mind, this is our universal set. So if we're going to identify a set within the universal set, let's give it a name. We're going to call this set A. So we're naming it set A, and so we can say now something along the lines of set A is the elements of a jack, a queen, and a king. And so that would be all the proper notation that we would use to identify that set of face cards within a deck of cards. So moving on down the list. So again, as far as just making sure you note things properly, the correct statement is when you identify an object as being an element of a specific set, what's just the proper way of identifying that? So if we were going to take this example from what we just looked at right here, switch to darker, make sure you guys can see, we could say something along the lines of a jack is an element of set A. And so we could either give it the name or we could actually identify the specific set, and you could say something like a jack is an element of this set right here. And so we could identify it either way. So if you're just going to give the name of the set, right, you wouldn't put braces around that. But if you're actually going to list the set itself, then we do put braces. And so those are just two ways that we could identify one of the objects within that set. Right down here, so the little slash through the E just means is not an element of. So for example, if this is set A right here, one of the things that we could identify that's within a deck of cards but not a part of set A, if we're just going to pick one at random, so let's just say the 8s within our deck of cards, we would say something like an 8 is not an element of set A. And so that's one way we could write that. And again, a lot of this has to do with proper notation and symbols, so make sure we understand when to use these braces and when not to. So that's going to be important for us. So moving on down into set builder notation, last couple examples down here. So with set builder notation, so we do have still the braces identifying a set, but with this one a little bit differently. They identify a specific variable that's being used, and then they define what that variable represents. So if you look at this one right here, this says x's such that, and this is kind of your symbol for such that, x is all odd numbers. So if we're going to put that into set builder notation, so let's just identify this as set B. So we're just going to give it a name, and so we're going to say something along the lines of set B is equal to, and then here's how we use this set builder notation right here. And so we start by identifying the variable. So we're going to identify the variable as x's such that x is all odd numbers. And there's no way for us to list every odd number under the sun. So because of that, we simply have to just do it in word form and say all odd numbers. And so that's going to be the case where there are some cases if the set is small enough, like with the jacks, queen, and kings, you could literally identify the specific values. But if it's too big of a set, like all odds, there's no way you could list all the odd numbers. It's an infinite list, and so we were just going to do it in word form since we can't really list the specifics. Right here for example 3 though, so here's going to be a case where we can start identifying some specifics. So for example 3, they're giving you something in set builder notation already. So this is already in set builder notation, and they want us to identify the elements that are in that set. And so within set A, we have all x's such that, and then they give us this equation right here. And so it's our job to identify which x values would satisfy that equation. And so we know with what things that we've done before that if x plus 3 is equal to 0, then we know that negative 3 is an element of that set, and if x minus 4 equals 0, then 4 is also an element of that set. And because I am making a list of elements, I got to use the braces to identify my list of elements that are a part of set A. So moving on down, so if we're going to list the elements of set B, and again they're going to give us another equation right here. So if we were to look at this, so they're saying, okay, set B is x's such that x squared equals negative 9. Well, if we were to solve that equation, so if I said, well, if x squared equals negative 9, and I were to solve for x by square rooting both sides, well, what's the square root of negative 9? We can't do it, right? So in the past, you would identify that as a no solution case. So there's two ways to identify a no solution case. One way would be to say that set B is equal to, and we just leave the set empty. Because there are no solutions, there are no items to list, there are no elements to list, and so we just leave it empty. And so an empty set is one way of identifying a no solution case. The other way to do that is there is a symbol that you've probably used in the past where you just kind of make a 0 with a line through it, and that works too. So you could either just do the empty set, or you could do this notation right here, and both of those refer to kind of like a no solution kind of a case. So to finish things off here, you're going to run into some true-false questions that you'll be tested on, and these are all about knowing the rules as far as how you properly name something or which symbols you're supposed to use, and so you just got to be careful that that things are properly identified with the use of symbols. So if you look at the first one right here, and so here is set A, and so all this is going to be referring to set A. And so if you look right here, it says that 3 is an element of set A. And so we're looking up here and seeing if that's true, and we can see that that's true. 3 is definitely an element of set A. And we just got to make sure that everything was used with the proper symbols. And they were on this case, and so we can safely say that 3 is an element of set A, and the proper symbols were used, and so we could say that that is a true statement. If you look right here at number 2, so A is an element of set 7, and so if you look up here, they kind of did that backwards. Are we allowed to say that A is an element of set 7? Right? Obviously not. We could switch that around and say that 7 is an element of set A, but the way this is written, it's out of order, and so this would be a false case. And then one more case right here says that 11 is an element of set A, and if you look at set A, right, we can see that there's no 11 in there, and so 11 is definitely not an element of set A. And I'm going to give you one more case here, and this is something that people often overlook and get this wrong, and here's where you need to know your symbols. One case that they will give you that is false, and I'm going to show you with the first example that I did right here, but what if I were to say that 3 is an element of set A, but I put braces around the 3? And so what if I did this? Right, and put braces around the 3 and asked you the same question that I asked you here, is 3 an element of set A? And then people will look at this and say, well, yeah, 3's in there, so that's got to be a true statement. But the issue here is the wrong symbols were used. You're not allowed to put braces around a specific element like we did here. And so this would be a false case. So you just simply because the wrong symbols were used. And so in this case, you're being tested on the use of symbols and notation. And so that takes you back to what we said way back up here at the start of this, that when you list a specific element within a set, you don't use braces. And so that's why that last one would be false. So just pay attention to the proper use of symbols and notation as you move throughout this chapter.